Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syakab from Mechanical Engineering Department, Diponegoro University, Semarang. I will present my research about analysis of the journal bearing performance, considering artificial surface roughness and cavitation using CFD FSI method. At the introduction, a journal bearing is one of the machine elements that are widely used in various types of industrial machines, such as the shipbuilding industry, transportation equipment, pharmaceutical product, and food product. Journal bearings are preferred in the industry because they have advantages such as easy installation, low maintenance cost, high damping capacity, low manufacturing cost, easy manufacturing process, and long service life, and can withstand heavy load and high speed that are stable and safe, even though they are used at high loading, speed, and precision in a combustion engine, turbine, compressor, and pump. In the bearing production process, there is a grinding manufacturing process. Grinding is the process of reducing the particle size of material from a coarse to finer size to improve the mixing process and avoid the segregation of the material particle. This grinding process affects the level of roughness on the outer and inner surface of the bearing. This level of roughness has a very large effect on the performance characteristic of the bearing. Numerous research studies has demonstrated that surface roughness has an effect on the thickness and performance of lubricating oil coating. Surface roughness should be taken into account in study, particularly for thin film lubrication, as it is equivalent to the film thickness. And the purpose of this research, by addressing cavitation effect, this study investigates the impact of surface roughness on the journal lubrication performance, like pressure, load support, and deformation. And the method, we use the K epsilon turbulent model, is used for Newtonian and incompressible fluid. And the surface roughness is assumed to follow the uniform sand grain roughness model. Numerical analysis with two-way fluid structure interaction method is used by considering the cavitation model of snare shower. And for journal bearing dimension, we can see that this is a journal bearing dimension. The length of bearing is 133, and the housing thickness is 50 millimeter, and the roughness parameter RA is 0.1 micrometer, 0.4 micrometer, 1.6 micrometer, and 12.5 micrometer. And then the simulation setup, we use model K epsilon turbulent, fluid Newtonian incompressible, and we use step size 5 and maximum interaction is 20. And the result of my research, one is pressure distribution. In pressure distribution, we can see that with increasing the surface roughness, RA, from 0.1 to 12.5, we can see that the pressure distribution decrease. For hydrodynamic and elastohydrodynamic, it's same, the phenomena. In elastohydrodynamic lubrication, there is a shift in pressure distribution due to deformation of journal bearing. From this result, it can be seen that roughness parameters such as RA should be considered in the design factor for journal bearing with small film thickness. So we can see for hydrodynamic and elastohydrodynamic, there is a shift of distribution pressure. The next, about the load support, we can see with increasing the surface roughness from 0.1 to 12.5, the load support decrease. And the decrease in load support occur because of the unlubricated area. This is due to deformation of the shaft and housing, which result in lubricant starvation. And we can see that the degradation from 0.1 RA to 12.5 is about 7.3%. The same for hydrodynamic and elasto-hydrodynamic. And we can say increasing surface roughness will decrease the load support. And the next, about deformation, we can see from this table, with increasing surface roughness from 0.1 to 12.5, the deformation will decrease. This deformation reduction is possible due to the lower hydrodynamic pressure of lubricant, which is the main parameter for deformation of the shaft and housing. And we can see from this figure, the red color, this is the maximum deformation, and the blue color is the minimum deformation. And we can say with increasing surface roughness, it will decrease the deformation. And the last, the conclusion is from this research. In elasto-hydrodynamic lubrication, there is a shift in pressure distribution compared to hydrodynamic lubrication caused by deformation of the bearing. Therefore, the FSI CFD method should be used in conducting the analysis. And the next conclusion, the numerical analysis revealed that increasing surface roughness will decrease the pressure, load support, and deformation. And the last conclusion, the performance of the journal bearing can be improved by applying artificial surface roughness. Okay, and thank you for your attention. And wassalamualaikum warahmatullahi wabarakatuh.